Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is smaller sum. It is a medium level problem. So it says that we have been given an array of n integers, and for each index I, we have to find the sum of all the integers present in the array with a value less than array of I. Right. So let me just take some test case. So this is the first sample test case that has been given to us. So what we essentially have to do is the input array is 1, 2, 3, right? So there are no elements smaller than 1, so that is why its value would be 0. There is one element smaller than 2, and that is 1 itself, so the value would be 1. There are two elements smaller than 3, and their sum is 3, so the value would be 3 here. Now if the order of the initial array changes, the answer would be still the same, just the indexes of the answer will also change corresponding to the input, right? So if there is any particular input, for example 1, 2, 3, 4, the answer will always remain the same or will always have the same values for all permutations of this particular input, right? Thus the answer will also change indexes according to the input value. So if you see 3 was initially here, now the 3 is here, right? With the 3 corresponding to in the original array. So this is the very important thing about this question. So that means we just have to be careful about the indexes, otherwise the answer only depends on the value of the elements. It does not depend on the ordering of the elements, right? Now the second thing is what you can do is first let us discuss some brute force approach of solving this question. Brute force approach or a very simple approach like which you can think of. So the constraints n is up to 10 raised to the power 5 and ai is up to 10 raised to the power 9. Right, let us take this. So what happens in the brute force approach is you take any element, right? You just traverse through the array. At the ith index, you take any element I, and you again traverse through the whole array, right? With the pointer j. Whenever a of j is less than a of I, we just add it to my sum or my total answer for a of my total answer for I, index I, right? So at the end, what I'll do is just do it. Answer of I is equal to sum. So this would be my brute force approach in which I traverse through the array in a n square loop. So if the constraints on n were small, then this would have definitely worked, and we cannot use it in this particular question because n is up to 10 raised to the power 5. So this would definitely give us TE. Now let us optimize this approach a little bit. We know that I've already discussed that only the value of the input elements is important. Their relative position is not important. It's just that if the element is present at last, then its corresponding answer will also be present at last, right? So if I know that these are the certain values that I have in my input, I can always calculate the answer for them and place my answer values according to the indexes of the values in the initial array. So what I can just do is I can create a copy of the input array. So for example, the input was 3 to 1. Let us take this example. So let me just create a copy and I'll be storing it in a pair. So 3 0, 3 0 means that 3 is the value and 0 is was its initial index. And 2 comma 1 and 1 comma 2. So this is what I'll be storing. Now if I sort this particular vector of pairs, so this is a vector of pairs. Right, if I sort this, what I'll get is 1 will go to the starting, 2 will go to the second position and 3 will go to the third position, right? So you see this was actually similar to the original input array that we have got in the sample test case, that is 1 comma 2 comma 3, right? So this is the same array 1, 2 and 3. Now I also have the indexes of the array elements that this was the original position of this particular element in the original input array. Now since I have sorted it, their position must have changed. They might or might not change, but I'll be having the index values. So now what I do is I can just easily calculate the prefix sums of all these values. So here the value will be 0, here the value would be 1, here the value would be 3 and here the value would be 6. So these are the values of prefix sums. Now since I have this in sorted order, I can easily perform binary search on it, and the value I binary search on is For example, I'm traversing through my array in a loop. So if I'm at index I and the value is a of I, so I can perform a binary search on a of I comma minus 1. So I'll be using the STL library for binary search provided by C++. So I'll be using lower bound here, right? So lower bound will return me the first occurrence of this particular element as a whole, or it will return me the element just greater than this. So actually it is going to return me a of I comma some index, right? So this index would be some positive value. Now what happens is, I don't need, for example, if I am at this position, I did binary search of 2 comma minus 1, it will return me the pointer to this particular element 2 comma 1. Since 2 comma minus 1 is not present, it will return me the element just greater than it, that will be 2 comma 1, right? So I don't need the answer for this particular value because the answer would be 3. So I'll I'll just move my pointer one place to the left and I'll be pointing to this particular location, and pre of this particular value will be having my answer, right? Pre, let's say this was indicated by post. So let's say this is the position or of the index. I'll do my final answer will be pre of position minus 1. So this would be my final answer. Now where do I store this answer? So if I was at index I initially and I was looking for a of I comma minus 1, then definitely my answer would be, so let's say that this is the input vector, my answer would be in input of, and I'm looking for the ith index. So input of I, you can see I stored the index in the second value, so I can do I at second, right? So this would be the final index I have to store my answer. So answer of input of I dot second will be equals to pre of position minus 1, right? This is how am I going to solve this particular problem with binary search, right? So essentially what I have to do is I have to sort the input vector, I have to calculate the values of prefix sums. Now whenever I'm at a current at any particular value, what I can just do is I can search for it as a pair, because the second index will denote the index, right? Second element will denote the index. It will always have a value greater than or equal to 0. So I can do a binary search on ai comma minus 1. So this will return, so for example, if there were multiple occurrences of 2, so let's say it was something like this, 2 comma 0, 2 comma 1, let us change this particular value. Let's say this is 2 comma 5, 2 comma 7 and 2 comma 8, and there was some value 1 comma 4, right? Let's say it was something like this. Now I don't care about these particular 2's because they are present at the last, and if I include them and I do minus minus pointer, I will reach this particular position. I don't need the value from this particular position, I need a value from this particular position, because pre till this particular position will be having the sum of all the values from here, which is lesser than 2. So if I want the sum of values lesser than 2, then what I'll have to do is I'll have to get to this position first, then I can just move one position backward and I can have my answer from here, right? So what I'll essentially do is I'll do binary search on the value 2 comma minus 1, which will return me this particular position, since this is the value just greater than 2 comma minus 1. 2 comma minus 1 will never be present in my array because the second part is an index and it can never be negative. So it will return me the first occurrence where 2 is a value, right? So I can just go one place to the back and I can just add the prefix sums at that particular position to my answer. So this would be the final approach. Let me just quickly summarize what I just did. I'm sorting the vector and also storing the indexes, because taking care of the index is important. I'm just doing binary search on the value and I'm just storing it in my answer, right? So this would be the solution of today's problem of the day. And now let us have a look at the code. So what I'm doing is I'm actually creating two different vectors apart from the input array so that I can store the information here. So what I'm essentially doing is I'm creating input array of size n plus 1. So this would be storing pairs of n comma n, and I'm also calculating a prefix sum vector of size n plus 1. Now prefix of 0 is 0 and input of 0 is minus 10 comma minus 10. So like there is a very interesting story why I took minus 10 and minus 10. So the important thing about this particular pair should be that it should never be these values. The first value should never be present in the array. So according to the constraints, the value of a of I was starting from 1. So I took it as 0 comma 0. So initially I wrote it as 0 comma 0, right? So this was my first initial intuition. But when I run my code, like it failed on some sample, it failed on some test cases because the input array had an element 0, right? So the constraints mentioned that it will not have zeros, it will have value starting from 1, but it had zeros. So that is why my code failed, and I have to take it some value smaller than 0, right? So that is why you need to take care of this, that this first value should always be should never be present in my array, and it should be smaller than all the values that are present in the array, right? Now, the next thing that we do is we just traverse through the array and set the values of first and second. So the second will have the index, and I'm storing the zero based indexing here, and at all since this is also zero based indexing, the input array ARR. That is why I'm doing I minus 1 and put the positions, and my input in the prefix sums array will be in by 1 based indexing. So the next thing I do is I just sort the input array, and I also calculate the prefix sums. So this part is very simple. I just do pre of I is equal to pre of I minus 1 plus input of I dot first, since the first value of the pair is storing the value. Now I create my answer vector of size n. Now the next thing I do is I just do lower bound on it, and it would be from input dot begin till input dot end, and what I'm searching is input of I dot first. So this is I'm making a pair. I'm searching for input dot I dot first comma minus 1. Right, this is the part I have already explained, and I just subtract input dot begin from it, from the whole value, so that I get the index in the position value. So I just decrement the value of position by 1, and I just set my answer of input of I dot second. So input of I dot second will be storing the actual index of the value in the original array, and I will assign it value pre of position. Right, at the end I can just return my answer. So this would be the solution for today's problem of the day, smaller sum. I hope you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to subscribe to the channel. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.